All right, so here's your support on the AP Classroom assignment. So you are required to do your work, to show your work, and then to submit your answers on the College Board website. So I'm going to help you through if you have any issues at all with this. So number one is hopefully a simple question. Can you take the derivative of 2 to the x? So if I think I need to give you support, I will. If not, I won't. So just take the derivative of 2 to the x, show what the answer is, circle the right answer, and then move on. So you can look at your notes to know what the rule is when the base is not e. Number 2. Here you're given a function, e to the x, and then it says ln of the derivative at 2, what would that equal? So for this one, the first step is to take the derivative of e to the x. I think that's an easy rule. Then the next step is plug 2 into that derivative. So now you have an answer. And then the last step is to plug that answer into what's given, which is ln and then simplify that and then find the answer. Number 3, let f be this function, and let g be remember the symbol -1 means inverse. And then it says, for the inverse, you know g at 2 equals 1. So I want to organize it just a little bit. So f at x and g at x are inverses. On g, you're given the point 2, 1. So if I inverse it, that means on f, the point is 1, 2. If I find the derivative at 1, then the reciprocal of that will be the derivative at 2, right? So if I kind of organize this. So when I look at f at x, I want to take the derivative of f at x. I then want to plug in 1 into that derivative. And then when I get the answer, I then want to do the reciprocal of that and then find what the answer is. So then when you turn the page, then you have these options. So again, I encourage you to print this out if you can, but if you don't have a printer, then you're going to have to write out each question, solve it, and then show me, clearly show your work that you're doing the work for each one. Number 4, you're given a function, and you're asked to find the derivative at 2. So my support here is e to the 2x, x cubed plus 1. This is the product rule. So when you take the derivative, you have to go the first times the derivative of the second plus the second times the derivative of the first. And don't forget the hook of 2 that needs to be a part of it. And then once you take the derivative, plug 2 in, and then find the answer that matches. So make sure you show your work of the derivative. Make sure that you show your work that you plug 2 in and simplify it, and then find the answer that matches. Number 5, y equals ln x divided by x, and then take the derivative. So my clue for you here is, because you're dividing, this is going to be the quotient rule. So show your work. What is the quotient rule? It's the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. Then, when you turn the page to the next one, you can see which one is actually using the quotient rule properly. And then you circle the one that matches. 6. If ln 2x plus y equals x plus 1, then what does the derivative equal? So here's an example of implicit differentiation with a logarithm. So whenever you take the derivative and y is involved, then you need a y prime. So if I started this for you, the derivative of ln 2x plus y, what you see is the denominator. The derivative of this is the numerator. Well, the derivative of 2x is 2, and the derivative of y is y prime. And then on the right side, the derivative of x is 1 and the derivative of 1 is 0. You now need to do the algebra to get y prime by itself. So I would multiply both sides by 2x plus y, subtract and then do the algebra to get y prime by itself. Number 7, and show your work. In number 7, we have an integration problem from 1 to e. So you're given x squared subtract 1 divided by x, and you have to integrate this. So the way it looks right now, the indicator is this, that the numerator is more powerful than the denominator. So the degree on top is bigger. That's an indicator to know that you have to do long division. So that's what we're going to do. So make sure you do long division so that you can integrate this. So we're going to divide x into x squared subtract 1. X goes into x squared 1x, or you can just divide x squared divided by x to get the same answer. X times x is x squared. X times, there's nothing else there, subtract. So x squared subtract x squared, that's nothing. So if you bring down the next number, all you're left with for the remainder is -1. So to write this, we're integrating from 1 to e. The answer is x, and then the remainder gets written as -1 over x. And you can always see if you did it correctly. If you get common denominators and you combine them, it should equal what it was before if you want to double check. So we have to do long division when the degrees match or the degree on top is bigger. Then we do long division to be able to separate it, so then you can integrate each one separately. So now the challenge is, can you integrate x? So you add 1 to the exponent and divide. Can you integrate 1 over x? That's ln. Don't forget the candy bars. And then, and there's no candy, just the bars. And then we have to do a substitution at the end. So after you do this integrating, right, add 1 to the exponent and divide, and ln x, then you plug in the upper bound, then you plug in the lower bound, and then finish it. Make sure you show your work of how you got the answer. You will not get credit. Number 8. And then you can look to see which answers match. So one of those answers will match. What are the values? What are all the values of x which the function f defined by that is increasing? So in other words, where is this function increasing? So when I see the word increasing, I have to remember, how do I know if a function's increasing or decreasing? Like, what are the steps we use in calculus? And the answer is, we're going to take the derivative. So you're going to take the derivative here. Now, x squared subtract 3 times e to the negative x is the product rule. So you're going to go the first times the derivative of the second plus the second times the derivative of the first. Don't forget the hook on of -1 when you take the derivative of e to the negative x. Then, once you've taken the derivative, then you make it equal to 0. Then you solve for x, and those are your critical numbers. Now, the domain here is all real numbers. There's nothing x can't be. So it's going to go from -infinity to infinity. So when you solve for x, those critical numbers will go on the number line. Then you're going to test each interval out to see. And you test it by going back into the derivative and seeing if the answer is positive or negative. Then you label your number line. And if it's increasing, you're looking for where it is positive. So once you find the interval that it's positive, you then come back here and see what the correct answer is that matches up to it. Number 9, can you integrate this? So again, what do I notice when integrating this? That the degree on top is bigger than the degree on the bottom. So we can do long division, or we can do synthetic division to divide it. Notice the denominator is linear. So the 0 of the denominator is -2. And the numerator is 1, -1, -5. You could also do long division. And synthetic, you take the first number and drop it all the way down. Negative 2 times 1 is negative 2. Add, that's negative 3. Multiply, that's 6. And then we have a remainder. So it's important to know how to write this down. So now we don't have one fraction. 1 represents x. Negative 3, that's just a constant. So we're dividing. It was x squared, so our answer is going to have a degree of 1. So it starts with 1x, subtract 3, and then this is our remainder. So we go 1 over what we're dividing by, the divisor, which is x plus 2. So then each one you're going to integrate. So think, for x, you add 1 to the exponent and divide. Negative 3 is just negative 3x. And then this is going to be a logarithm. And then after you do the integrating, you're going to plug 2 in, you're going to plug 1 in, and subtract it, and then turn the page to find the answer. Make sure you show your work. Show. There it is. Make sure you show your work. And then one of those answers will match. All right, number 10. See if you can focus in here. Oops. So again, for number 10, I noticed the denominator is more powerful than the denominator. The numerator is more powerful. So again, and because it's not a simple linear on the bottom, you are going to have to do the dividing. So I want you to do this. You only have to do it once. So you do the dividing. Then when you have your answer, put it back in. Then integrate. And then don't forget the candy. So this is going to require long division. Go 12x squared divided by 2. So you can see how it's going to start, right? And then continue it from there. Number 11. The base of a solid is the region in the first quadrant bounded by the y-axis, the x-axis, and the graph y equals e to the x, and the vertical line x equals 1. So the first thing I want you to do is actually graph that. So the curve y equals e to the x goes through the y-axis at positive 1. And it has this curve to it. Now, that's y equals e to the x, and really that's the most important part to realize. It's in the first quadrant, so the left doesn't matter. And then the others are the y-axis, the x-axis, and then x equals 1. So there's x equals 1. And then it says the base of that. So I'm going to shade this in. This is going to be a solid from here. And that's the base of the solid. And it says each cross-section perpendicular to the x-axis is a square. So the formula for the square is, if you know the base, all you do is square it. So if we remember, if you're doing a cross-section, that's an integration question. We're going to integrate from what's the lowest x value to the greatest x value. So we're going to integrate that from 0 to 1. And we integrate the area formula, dx. So if I think, what represents the base of this square at any point, we would go top, subtract bottom. So the top is the function e to the x. The bottom, if we like, is y equals 0. So it's e to the x, subtract 0. It's the top, subtract the bottom. That would give me the base at any point in between 0 and 1. So the base is represented as e to the x, subtract 0, or just e to the x. So when I come back here, replace the a with the formula. So the base is e to the x, and I square it. So the area is take the base and square it. That's the area of a square. And we found the base formula as being e to the x. So I put this all together. So you can simplify this. E to the x and square, you just multiply the exponents together. And now the next step is to integrate this. So the derivative of 2x is 2. So it needs 1/2. And then you can unhook this. So then do the antiderivative. You plug in 1, subtract, plug in 0, simplify it, and then find the answer that would match after that. All right, number 12. In number 12, you're given that y equals x squared times e to the x subtract 1. Take the derivative. So my support is, this is the product rule. So it's the first times the derivative of the second plus the second times the derivative of the first. Show your work, simplify it, and then circle the answer. Number 13, what is the slope of the tangent line? So they're not asking for the equation of a tangent line, but just the slope. So the slope of a tangent line is another way of saying the derivative. And at this point, we have a derivative at a point, which is at x equals 1. So in order to answer this, we need to take the derivative of e to the negative x over x plus 1. This is the quotient rule. So that's the bottom times the derivative of the top. Be careful, it needs a -1 hook. And then subtract the top times the derivative of the bottom, and then the bottom squared. That's the quotient rule. And then when you do all that work, once you have the derivative, plug in +1, and then look for the answer that matches. So simplify it, and then look for the answer that matches. All right, number 14. The slope, and this is our last question. The slope of the line tangent to the graph. So again, I'm looking for slope of a tangent line. That's another way of saying derivative. And so the derivative here, we're going to do, so it's the derivative at x equals -1. So take the derivative. So do you know the formula? So what you see goes in the denominator. The derivative goes in the numerator. And then you plug in -1 and you answer it. And then you turn the page, and then the answer, see which answer matches that. All right, there's my support for the AP Classroom assignment. Make sure you take a picture of the work you did, submit it, and then make sure you go to College Board and go to your AP Classroom, and then select the answers, and then submit. That's it. Mr. G Math over and out. Until next time.